Imagine if every time you wanted to visit a Google, YouTube or Instagram, if you had to remember their long IP address like 8.8.8 instead of just typing google.com. That would be impossible, right? This is exactly the problem DNS solves it, and it's work like the phone book for the internet. Hello guys, welcome back to my channel. In today's video, we are going to talk about very important protocol, that is DNS. In the last video, we discussed the TCP IP model, and I told you that we will go on step by step by covering each and every important protocol in the TCP IP model. So today, DNS is the first one we are going to cover. Okay, if you watch this video till the end, you will not only understand DNS for interviews, but also help you in your journey to become a cybersecurity professional and also make network troubleshooting much easier. Okay, now let's look at the today's agenda. First we will start with what is DNS, then we will cover complete flow of DNS, how a request goes from the browser to DNS server. After that, we will look at different types of DNS queries. Then we will cover different types of DNS records. Okay, then we will move to the DNS zone transfer. Finally, we will examine the DNS packet header. Once we complete all these topics, you will have a solid understanding and be on your way to mastering the DNS. Okay, so without wasting any time, let's get started with the question, why do we need the DNS? We all know that computers talk to each other by using IP address, right? Let's imagine if there was no DNS. You should remember all the IP address of every website you wanted to visit. But we all know that humans are bad at remembering the numbers. We prefer name like a google.com, youtube.com or amazon.com. So DNS acts like a phone book for the internet. For better understanding, let's take a general example. Imagine you have a couple of friends and you need to talk to them every day. What do? You save their phone number in your contacts with their names. So whenever you wanted to call them, just search by the name and call them instead of remembering all the phone numbers. In the same way, when you type a website name, DNS protocols find the correct IP address and then you connect it to the particular website. So this is why we need DNS. Now we understand what is DNS. Now let's look at the definition of the DNS. DNS is used for resolve the domain name into IP address. So computers can find each other and connect over the internet by using domain name. You may have a question here. How do we actually get a domain names? Who provide these names to all the websites? For that, let's take example. Imagine you are building one application. Okay. So once it's built, you want to make it available for all the users, right? For that, what you need? You need a public domain. Okay. So the question is, how do you get a public domain and who provides it? Typically, we get domain names from the organizations called domain registrars. So these registrars companies are approved by ICANN. ICANN. It stands for Internet Corporation for Assigning the Numbers and Domains. So this is a global body that manages the domain names and IP address. Okay. Now we'll see the some popular domain registers are GoDaddy, Namecheap and Cloudflare. Right? You can go any of these, search for your domain what you want and they pay the fee to register it. Okay. For better understanding, let me open one of the popular registers, that is GoDaddy. This is a GoDaddy website. You can type domain what you want. Let me type network.com. You can search for the domain. See, you can see here different types of domain names by including network.com. Okay. Once you buy a domain name, so this domain is officially yours, no one else can take it. Okay, so we understood that how do we get a domain name. The thing is, once we got a domain name, okay, now all the user can access to my website. Okay, the next thing is we need to understand the complete flow between the browser and the server whenever the user is requesting for your domain. And this is a very popular topic in the internet world, and I have even faced this question in the interviews. So what we will do here, we will go through the complete journey step by step. We will also cover each and every component involved in this journey. Okay, so without wasting time, let's get started. Let's imagine our domain name is rakeshmetro.cyber.com. So this is a complete flow between the browser and server. Now you open your browser, you type the URL rakeshmetro.cyber.com in the search bar and you hit the enter. As soon as you press the enter, the browser needs to get an IP address for the domain. The first place it checks the browser cache. You might have a question here. What is cache? Cache is a temporary storage that stores frequently accessed data so it can be retrieved faster in the future. For example, let's say we are trying to access the rakeshmetro.cyber.com. Once the browser gets that IP address, it stores the data temporarily. The next time you try to access the same website, the browser doesn't send the request to the DNS resolver. Instead, it first checks the browser cache, retrieves the IP address directly if it is available. Okay? So in our first step, the request check in the browser cache. If there is no IP address stored in the browser cache, then the request will move to the operating system cache. Before we go to the operating system level, you may have a question here. How do we check the particular IP address present in the browser cache? Okay, there is a special URL where you can check the cached IP address. Let me open that website. So this is a website. Let me zoom in. Okay, let me search for the Google. We will see whether the IP address is there or not. See, you can see the IPv4 and you can see the IPv4 of the google.com. So this is how you can check the cached IP address in your browser. Okay. Coming back to our request, now our request will go to the operating system cache. Okay. How is the operating system cache differ from the browser cache? The browser cache only stores the DNS record for the domains that were requested through the particular website. For example, if you are using Chrome, it will only check the cache at the Chrome browser level. On the other hand, operating system cache stores the DNS record for all the applications and the browsers on the computer. This means it doesn't matter whether you are using Chrome, Microsoft Edge or Safari. The operating system keeps a centralized DNS cache that all programs can use. Okay? Yes, we have checked in the operating system cache, but we couldn't find the IP address in the operating system cache too. So what would be the next step? The next step is checking the host file. Okay? So let's understand what is host file. The host file is a place where you can manually update the IP address. It allows us map a domain name into IP address instead of just relying on the DNS. You don't need to buy a domain name. You can just manually update the domain name into IP address in the host file. How do we use the host files? When do we use the host files? Let's say your website is moving from new server with the new IP address. Obviously, the DNS record might take 24 to 48 hours to update across the internet. During this time, the host file can be updated point the domain directly to the new IP. Okay. Now we will see the host file. Yes, now we are in the terminal. Okay. Yes, you can see here host database. If you want to edit the host file, yes, this is the database. So first you should give the IP address. I am giving the Google IP address, and you should give the domain name. Okay, so this is how you should update the host database. Okay, now coming back to our request. Yes, we have checked in the host file. Unfortunately, we couldn't find the IP address in the host file too. Okay, so what would be the next step? How to get an IP address? Okay, so far we have covered all the activities that happened inside your laptop or computer. Now our request will move outside your system. The next step is the request go to the DNS resolver. Who is DNS resolver? Okay, the DNS resolver, also called ISP resolver, who is responsible for taking queries from your system and getting an IP address on your behalf. Now here the important thing, we also have a topic called queries. Okay, when your system sends the request to the DNS server, it uses a query. The query we call this as a recursive query, right? What is recursive query here? Okay, in the recursive query, your computer asks the resolver, please give me the final IP address of the domain, and also you should take everything responsible to get an IP address for the domain name. Okay, so along this recursive query, there are two more types of queries. One is iterative query and non-recursive query. Okay, we'll talk more about those later when we go through the next steps of the DNS resolution. For now, just remember, the recursive query means the resolver takes the full responsibility to go and find the IP address for your domain. And also you can check the DNS server setting on your system where your request is going. Okay, let me open settings. Go to system preference and type for network and go to advanced. Here you can see the DNS servers. Okay, so this is how you can see your DNS servers and the MAC. Coming back to our request, our system made a recursive query and the request reached to the DNS resolver. If we get an IP address from the DNS resolver cache, we call that query is non-recursive query. Okay, so once we get an IP address, we can access the website, but we couldn't find that IP address in the DNS resolver cache. What would be the next step? Okay, the next step is we need to reach out to the root server. So who is root server here? A root server is a part of the global DNS hierarchy. There are 13 root servers address globally we do have, but each has many distributed copies around the world. Actually, there is a website where you can check out all the root DNS servers. So this is a website. You can see all the list of the root servers. But you may have a question here. The DNS resolver sent the request to which root server? Since we have a 30 root servers. So every DNS resolver comes with a root hint file. Which file? Hint file, which contain the list of 13 root server addresses. Using these files, the resolver can contact the fastest and nearest root server. Okay, so now resolver found the nearest root server. So now the DNS resolver will make a query to the root server. The query which is called iterative query. Okay, if you remember, from your system to the DNS resolver, we used a recursive query. Now we are using a iterative query, but it works differently. How does it work? Instead of providing the full answer, the server responds with, I don't know the final IP, but it suggests that another server might know. So it does not give the IP address. It just points you to the right direction. Okay. So now our request go to the root server. Now what will root server do here? Will it give the IP address? No, it won't give the final IP address to you. It just give you the top level domain IP. Okay. What is top level domain? If you observe, every URL ends with the top level domain. For an example, in our request, rakeshmettu.cyber.com. .com is the top level domain. Okay, so we do have different types of top level domains such as .com, .organization, .edu. Each TLD has for different purpose. For .com, it is for commercial and business websites, and .org is organizations. .net is it used for network services or internet infrastructure. .edu is it for educational institutes, and also we have country codes like .us, .uk, etc. We do have different top level domains. The reason we use top level domains that organize the domains and also to make website easier to identify and to help with the DNS resolution. Okay, coming back to our request. Now the root server check your request for rakeshmettu.cyber.com. Okay, it responds with the IP address of the .com TLD server since we are using TLD.com. Okay, so this response go back to your DNS resolver. Okay, now we got the IP address of the .com of the TLD server. So now the resolver make an iterative query to top level domain, but the TLD server doesn't know the final IP address. Instead, it knows the authoritative server of the second level domain, which is cyber.com. Okay, so what is the second level domain? How it's differ from the top level domain? The second level domain is a part of domain names directly under the top level domain. For example, rakeshmettu.cyber.com. .com is the TLD, cyber is the second level domain. The reason we maintain the second level domain is to organize website under the top level domain. This is also help to create unique names like example.com, google.com and amazon.com. Okay, coming back to our journey, the .com TLD server gives the IP address of the second level domain for the cyber.com. Okay, now the resolver contact the SLD for Authoritative DNS server domain. Okay, so SLD give an IP address of the Authoritative DNS server. So finally we got an IP address of the Authoritative DNS server IP. Okay, this Authoritative DNS server actually hosts all the DNS records. So now the resolver contact the Authoritative DNS server for rakeshmettu.cyber.com by making the other iterative query. You may have a question here. Once we reach the Authoritative DNS server, we see different DNS record. Okay, what do you mean by DNS record? And what are the types of DNS records? Let's understand about the DNS record. Okay, so to get an IP address, which record should we look for? To answer all of this, we will see the DNS records. First, let's understand what is DNS record. A DNS record is an entry inside the DNS database. It contains all the DNS information about your domain. Each record has two parts. The first one is type, what kind of information it holds. Second one is value, the actual data it stores. Okay, so let's understand the records one by one, and also this is a interview question too. Okay, the first record is A record. A is used for map the domain into IP address. It stored the IPv4 in the A record. Okay, so move to the next one, that is 4As. It is used to map the domain name to IPv6. It stored the IPv6 address in the AA record. Okay, move to the next one, that is CNAME. CNAME stores the subdomain alias to another domain. Okay, so it stores the subdomains. Let's take one example like www.example.com. So it's mapped to the example.com as a subdomain. Okay, move to the next one, that is MX record. This is used for mail servers. It is used to make the communication happen between the two different mail servers like Gmail or Yahoo.com. It will store the mailing information in the MX record. Okay, so this is all about the MX record. Okay, move to the next one, that is TXT record. What is TXT record? This is something where we can store the text information like SPF and DKIM verification. So these are used in email authentication. So we will talk more about in the SMTP protocol. Okay, the next one is NS record. what does it store? It points the authoritative DNS server for your domain. Okay, which tells the internet what are the servers are responsible for answering the DNS queries for the domain whenever someone accesses your domain. Okay, so that is the purpose of NS record. Okay, move to the next one, that is SOA record. This provides administrative information about your domain, including the primary name server and the email of the domain and zone transfer information. Okay, so this is mostly for DNS management, not for end users. Okay, move to the next one, that is PTR record. So this record maps an IP address to the domain name. Yes, you heard right. It's mapped an IP address to the domain name. So it is the reverse of an A record. This is used in email server for spam prevention, verification and other purpose. Okay, now move to the next one, that is a special type of DNS record, that is SRV. So it tells the client which server provides a specific service for a domain along with the port number and priority to connect. Okay, the reason we use SRV record, because not all the services run on the standard protocols and port numbers like HTTP and HTTPS with port number 80 and 443. Some application need to discover dynamically which servers to connect on which port. Okay, and also if multiple servers exist, SRV also can specify which one has the highest priority. So all this information stored in the SRV record. Okay, move to the final one, that is CAA record, Certification Authority Authorization. So this specifies which certificates authorities are allowed to issue a SSL TLS certificate for your domain. We will talk more about in the SSL handshake. Okay, so this is all about the DNS record. Now coming back to our request, we are at the authoritative DNS server where we can see the number of DNS records. You tell me which record will give you the IP address. Yes, the A record will give you the IP address to the DNS resolver. Once the DNS resolver gets that IP address, it will return to the browser. Then the browser can connect to the server. So this is all about the complete journey of the DNS. Okay, let us quickly recap the complete flow of DNS. It will strongly inject in your mind. Okay, so first, when you type a URL in the browser and hit enter, the browser will check it a cache. If the IP address is there, it will use it immediately. If it is not found, then it moves to the operating system cache. At the OS level, the cache stores IPs resolved by previously by any application such as Chrome, Edge, Safari, etc. If an entry is found, it will return the IP address. If not found, it moves to the host file. Okay, so the OS then check the host file, which can manually map domain into IP address. If an entry exists, it will return the IP address. If not, it will go to the DNS resolver. Okay, if all local check fail, the query goes to the DNS resolver using recursive query. Okay, the resolver first check its own cache. If the entry is there, it will return the IP address. If not, the resolver starts a DNS resolution journey. Now the DNS resolution has a hint file that contains the address 13 root servers. The resolver contacts the nearest root driven server. Okay, the root server don't know the final IP address, but they do know where the TLD servers are. Example like .com TLD servers. Okay, so the root server responds to the resolver with an IP address of the TLD server. Okay, now the resolver contacts the .com TLD server. The TLD server doesn't have the final IP address, but it knows the second level domain. Okay, then the resolver make a iterative query to the second level domain. The second level domain server responds the information on the authoritative server. Finally, resolver make a iterative query to the authoritative domain server. Okay, this server actually holds all the DNS records such as A, CNAME, MX, TXT, etc. To get that IP, the resolver looks for the A record or AA record. So the authoritative server responds with the IP address. Now the resolver returns the IP address to the browser. So finally, the browser can connect the web server hosting the website. So this is all about the complete DNS journey. Okay. So if you want to see the DNS records, let's say we want to see the DNS record for google.com. So we'll talk more about the command in the network troubleshooting video. So here you can see all the DNS records. See, A record is mapped to the IPv4, A record mapped to the IPv6, NS is record for authoritative DNS server, TXT, verification. So you can see all the list of DNS records. Okay, so this is how you can check the DNS records. Okay, now let's move to the one of the favorite interview question. What ports and protocols are used by the DNS? The default port for DNS is 53 we use. So what protocol do we use? Actually we use both protocols, UDP on port 53. Most DNS queries use UDP because it's a lightweight, fast and has less overhead. Since DNS queries or response are usually small, so UDP is a perfect. So when do we use TCP then? TCP on port 53 used in the special cases such as when the DNS response is too large to fit in the UDP packets. For example, with the DNS sec or large records, or for zone transfer between the DNS servers. So in short, UDP is for normal everyday DNS queries, TCP is special case like large responses and zone transfer. So this is all about the ports and protocols about the DNS. Now we will see the another interesting topic. What is zone transfer? Why do we need it? Let's look at the definition of the DNS zone transfer. DNS zone transfer is the process of copying one DNS record from the primary server to secondary DNS server. It ensures that multiple DNS servers have the same up-to-date information about your domain. The reason we maintain the zone transfer is, the first one is redundancy and high availability. If one DNS server goes down, another server can still answer queries by redirecting the traffic to the secondary DNS server. Okay, this is one of the reasons. The second one is load balancing. Instead of one server handling all the DNS requests, multiple servers can share the load for not affecting the one DNS server. So these are the two primary reasons we use DNS zone transfer, and also zone transfer always use TCP and port 53 as we discussed in the DNS protocols and ports. There are two types of zone transfer we use. Okay, what are the types of DNS zone transfer? The first one is authoritative zone full transfer. It copies the entire zone transfer from primary to the secondary server. So when do we use? When a secondary server set up for the first time, or when a full refresh is required for the server. So that time we will use authoritative zone full transfer. Okay. The next one is incremental zone transfer. Okay. So when do we use incremental zone transfer? It transfers only the changes made in the primary zone. Let's say if you have made changes in the primary zone, so only the changes will be transferred to the secondary zone. So these updates the secondary with just a modification since the last transfer. Okay. So this is all about the DNS zone transfer. Okay. Now let's look at the interesting and final topic, that is DNS packet field. This is very important to understand the packets in the real time. Okay. Let me open a website and we will see the DNS packet headers. Let me zoom the screen. Here you can see the different packet fields. Let's go one by one. The first one is transaction ID. Every DNS query has a transaction ID. It's just a random number. Once the request goes to the DNS server, the server replies with the same number in the response. So this helps our computer know the particular answer belong to the particular question. It is also avoid the confusion when multiple DNS queries are happening at the same time. Okay. The next one is flags. These are the control bits. They tell what kind of message this is, whether it is a query or a response, whether recursion is desired, or if these are the errors. Okay. You can see the different flags here. Okay. The next one is questions. This tells what is the client is asking for. For example, what is the IP of the google.com. So this is the query you are looking for to get the IP address for the particular domain. Okay. So this is all about the questions section. Basically, you will see the questions here. Okay. The next one is answers. This section contains the response from the DNS source records. For example, you may say google.com, it's mapped to the IP address that is 8.8.8. Here you can see the actual IP address. Okay. The next one is, and final one is authority. So this points to the authoritative DNS server for the particular domain. It tells who is the authoritative server for the domain to the respond queries. Okay. So these are the important packet fields everyone should know. Once you understand this, you can able to easily troubleshoot the issue. So this is all about the complete DNS. I hope this gave you the clear idea about DNS. That's all for the today's video. If you find this helpful, please share it with your friends and don't forget to subscribe. We'll meet in the next video with another exciting topic. Until then, take care. Bye bye.